This is division by t theorem. As I told, Laplace of f of t upon t, which is equal to integral s to infinity f of s into ds. Now, before I have to start a problem solving, first of all I have to make a clear two concepts. The first one is, always remember, in a 12th standard all of you aware about this concept, the integral 1 upon x square plus a square into dx, which is equal to, hope all of you are aware about the integration of this function, that is 1 by a tan inverse of x by a. This is our concept, that is integral 1 upon x square plus a square into dx is equal to 1 by a tan inverse of x by a. Tan inverse of x by a plus c when the integration is undefined. And one more thing is integral f dash of x upon f of x into dx. What will be the integration of this function? It will becomes log of f of x plus c when the integration is not defined. If it is defined, you have to put the value of the upper limit and subtract the lower limit. So upper limit minus lower limit. Now this is why I cleared this two concept, because in division by t theorem, when you have to calculate the Laplace transform of the function must be in terms of sine and in terms of cosine. Why I said that is a sine and cosine, I'm just clarify these things. Laplace of sine of 80, Laplace of sine of 80, hope all of you are aware about a upon s square plus a square. Just see this concept, s square plus a square, which can be clearly defined, that is x square plus a square, and the numerator is treated as a constant. The constant is treated here as a. So please remember these things, x square plus a square, because in Laplace transform we are treating as t variable or conversion of t variable into s variable, that is a time domain to frequency domain. So here we have to treat the variable as s instead of x. So please try to understand, that is s square plus a square, the denominator see itself, that is s square plus a square. And suppose if I have to calculate the Laplace transform of cos of 80, so what will be the Laplace transform of cos of 80? That is s upon s square plus a square. See here the denominator, again the denominator, both the denominators are same, but the concept is the numerator. In sine the numerator is constant term, but in cosine the numerator term is variable term. So in the first part, that is integral 1 upon x square plus a square into dx, we are having only constant in the numerator, but in cosine terms in numerator there is a variable. So that's why whenever we have to calculate the Laplace of sine functions, we have to use the first formula instead of the second. But whenever we have to calculate the Laplace of cosine terms, not even cosine terms, or we can say that, suppose Laplace of e raised to 80, what will be my Laplace of e raised to 80? It will becomes 1 upon s minus a, 1 upon s minus a. So this part is clearly mentioned, that is this is not a part of this integration. But when I have to check, that is a derivative of this function can present in the numerator, so it is clearly mentioned, that is derivative of s is equal to 1, which is present, and derivative of a is 0, which is again here, that is only we will get 1. So we can say that the second formula is used for whenever we have to calculate the Laplace transform of cosine as well as the exponential. So for sine terms you have to remember this formula, and for cosine terms and exponential you have to remember this formula, that is integral f dash of x upon f of x into dx, that is equal to log of fx. Okay, now I'm going to define few more terms here. Okay, now always remember log of infinity, which is clearly mentioned, that is a 0. Please remember this thing, log of infinity is equal to 0. So you have to use this concept clearly in applying of a upper limit minus lower limit, because our main thing is Laplace of f of t upon t, which is equal to integral s to infinity f of s into ds. Again I am repeating this term, there is not a that is having a different work. You have to calculate the Laplace of f of t, as in a definitions I clearly mentioned, that is Laplace of f of t is equal to f of s. So whatever the function is given, you have to just calculate the Laplace transform of that respective functions. Whatever the Laplace will come after the calculation of the Laplace transform, you have to just you have to just use in terms of integration, that and that integration is defined in a limit, that is integral s to infinity. So please remember these things. Now I am going to start the first numerical, which is equal to, or the first numerical we have to calculate integral 0 to infinity e raised to minus t into sine square t upon t into dt. Or sometimes this question will come in examinations, is like prove that integral 0 to infinity e raised to minus t into sine square t upon t into dt, which is equal to 1 by 4 into log of 5 sometimes. But sometimes it will comes like evaluate only this part, and sometime it will come as a show that or prove that or verify, that is integral 0 to infinity e raised to minus t into sine square t by t into dt. Now I am going to ask questions from your side. I can call any name or any students, because already I taught this concept. Or I am going to ask this question from Devani Yash. So please on your mic, Devani Yash. Yash Devani. Yash Devani. Mic is not working. Okay, fine. Okay. Jado Anushri, on your mic.
Yes, sir.
The question is clearly given, that is integral 0 to infinity e raised to minus t into sine square t by t into dt. What will be my first step?
The first step is sine square t whole Laplace लेंगे.
Okay, we have to calculate the Laplace transform of sine square t. What is the use of this e raised to minus t here?
E raised to minus. Sir, वो formula ही है.
What? Which formula? That's why I'm asking a question. Which formula it is?
Sir, e raised to minus st
Okay.
into f of t.
Okay, so the definition of, we have to compare the definition of Laplace along with these questions, right? Okay, thank you.
Yes.
Now you can
Thank you, sir.
off your mic. Okay, now see, I can ask anyone at any step, so please be active in a class. Now integral 0 to infinity e raised to minus t, I am just comparing this part with the definition of Laplace transform, 0 to infinity e raised to minus st into f of t into dt, so that I will get the part of this, that is s equal to 1, while comparing e raised to minus st with e raised to minus t. So please try to understand this concept clearly. Now I have to calculate one by one, or you can compute this part later or at last step, but it is always my advice you have to compare at first step, so that at the end there will be no hesitations regarding, that is whether I have to use the first shifting theorem or the definition. Because always remember in a mind, whenever the integral 0 to infinity is given, you have to start the computing with the definitions. So please remember this thing. Now we have to calculate Laplace transform of sine square of t. Now sine square t, we are not able to calculate directly the Laplace transform of sine square t. We have to convert this function into, that is a multiple. So for sine square t, we have to convert 1 minus cos of 2t by 2, and Laplace kept as it is. Therefore this part will becomes Laplace of, or 1 by 2 I am taking outside, so my or we have to calculate the direct Laplace, because already we saw such a kind of numericals. So 1 by 2 outside, and Laplace of 1 will becomes, I think, 1 by s, and Laplace of cos 2t, hope all of you aware, that is s upon s square plus 4, if I am not wrong. Now the next one is we have to perform, that is division by t rule. What is division by t rule? It is clearly mentioned in a numerical, whenever, that is, or in a statement Laplace f of t by t is given, you have to use, that is integral s to infinity f of s into ds. Now here it is given sine square t by t. So Laplace of sine square of t by t is given, we have to use integral s to infinity f of s. Now what is my f of s in this question? That is sine square t. Already we calculated, that is a Laplace of sine square t, and we got that is 1 by 2 into 1 by s minus s by s square plus 4. So we can take the value of Laplace of sine square t. So 1 by 2 as it is, I am taking here 1 by 2 as it is, and this part is 1 by s minus s upon s square plus 4 into ds, because we have to integrate this function with respect to s. So ds is mandatory here. Similarly, that is we have to apply, that is integration. So 1 by 2 outside I am taking because of a constant. Now what is the integration of 1 by s? So it is log of s, we can write clearly. But when we have to sort out this part, see, that is the denominator is carrying s square plus 4. It is the first type we can consider, but in a numerator it is clearly given, that is a variable. So we have to utilize the second rule, that is whenever the integral f dash of x upon f of x is given into dx, we have to use directly log of f of x. But the derivative of denominator, that is s square plus 4, will be 2s. So we have to multiply and divide by 2 here, so that the function will be clarified. So I am taking this part as it is, integral s to infinity 1 by s into ds minus, I am just separating this part by multiplying with ds. Now 1 by 2 I am writing here, and this will becomes my 2s upon s square plus 4 into ds. I just multiply with 2 and again divided with 2, so that the terms will be kept as it is. Now we have to use that is the concept, that is 1 by 2, or we have to apply the integration here. So we will get what? Log of s minus 1 by 2 log of s square plus 4. and limit point kept as it is, s to infinity, if I am not wrong. So the next work will be our 1 by 2 is kept as it is. While substituting the upper limit, we will get 0. Always remember, whenever the term is log present in this in such a kind of questions, please remember the upper limit kept as it is 0, and while applying lower limit you have to carry the negative sign with your side, so that the positive term will becomes negative and the negative terms will becomes positive. So the upper limit I am taking as a 0, while applying lower limit taking negative and applying s. So log of s kept as it is, because we have to substitute the value at the place of s. So s के जगह पे अगर s रखोगे you will get the exact value. Now minus 1 by 2 as it is, log of s square plus 4 kept as it is. So while simplifying this part you will get 1 by 2 into, I am writing this part as positive because minus into minus it will becomes positive. So 1 by 2 log of s square plus 4 and minus log of s, log of s. Therefore we have to apply the value of s here. So while applying the value of s, that is s equal to 1, where here. So I am writing here Laplace of integral 0 to infinity e raised to minus t sine square of t by t into dt, which is equal to, I am just substituting that is s equal to 1 in this equation. So I will get 1 by 2 log of, so while substituting 1 you will getting 1 plus 4, that is equal to 5 minus log of 1. So hope all of you know that is log of 1 is equal to 0, so that we got the result, that is 1 by 4 into log of 5. So this is our proof, or we can say that is, if the question will come like we have to evaluate the concept, so you must understand that is how to evaluate such a kind of functions. I am again going to revise this question clearly so that you will understand proper way. So from here we started the question, that is integral 0 to infinity e raised to minus t sine square t by t into dt, which is equal to 1 by 4, or sometime the question will come that is we have to prove. So I just started by the comparison or comparing with the function that is s equal to 1. So Laplace of sine square t, first we have to convert, that is a power function into multiple function. So 1 minus cos 2t divided by 2. Again we calculated the Laplace transform here. So Laplace of 1 is 1 by s and Laplace of cos 2t is s upon s square plus 4. Then next we have to use that is a division by t rule, because the function is divided by t. So we use that is integral s to infinity f of s into ds. But here in a question my f of s is, or my function is sine square t. So the Laplace of sine square t is present here, 1 by 2 into 1 by s minus s by s square plus 4. Therefore integral s to infinity will be 1 by 2 1 by s minus s by s square plus 4 into ds. Now we just separated this part and we make a form of integration, so that here the denominator is s square plus 4. So we multiplied and divide by 2 here, so that the function is completed, and we taken the integration in the format of like integral f dash of x upon f of x into dx, so that we got that is log of f of x format. So our integration of this part is log s minus 1 by 2 log of s square plus 4, and applied the limit point upper minus lower. So whenever the term log is present, always remember that upper limit is by default 0. So upper limit is 0 minus, when I substitute the lower limit at the place of s, the function kept as it is, but while applying upper minus lower, the negative terms will be positive and the positive terms will be negative. At the end we just apply here, that is s equal to 1 from the definitions. So from the definition, the s is equal to 1, so this part will becomes 1 by 2 log of 5 minus log of 1. Because of log of 5, why? Because s square plus 1, while substituting s you will get 1 plus 4, that is 5, and log of 1 is equal to 0, therefore it is that function is equal to 1 by 4 into log of 5. Hope all of you understand very well this numerical. Now I will move with the second numerical, so that our concept will clear very well. Okay, so the next numerical I'm taking here, it is a very, again a similar kind numerical is there. We have to utilize here. The second question is integral 0 to infinity. I'm taking integral 0 to infinity cos of at minus cos of bt divided by t into dt. Now my question arises again, I can call anyone here, so I'm going to ask with oxygen. Please on your mic. Oxygen, it's okay, your mic is also not working. Who want to take these questions? I'm not tell right now question, but who want to take question from my side? Anyone from 35 students? Okay, I'm calling with Pandey Akash. On your mic. Oh, mic is.
Yes, sir.
Okay. So in this question, again the definition format is given, integral 0 to infinity. So what will be the value of s here?
So S. Sir, it is. Sir, we have to first. Sir, S is not EM. This is not comparable, sir.
Yes, it is comparable. It is comparable. That's why I'm telling you that is it is clearly given in the format of definition, because our definition is clearly told, that is integral 0 to infinity e raised to minus st into f of t into dt. So I am telling you that is this is a format is given, because if the limit point is 0 to infinity given, means the question is clearly given in the definition format of Laplace. So my question again is, what is the value of s here?
So S is equal to 0. Then
Very
S to
good.
0 is 1.
Yes, very good, very good. Thank you. Now you can. So please understand this concept. I'm always telling, when the integration 0 to infinity is given, please understand it is the format of definition. So here that is e raised to minus t or e raised to minus st format is not given. So it means not like the value of s is not given. You just have to understand that is, if my value of s is 0, then e raised to 0 is 1. If my value of s is equal to 0, then e raised to 0 is equal to 1, and we can write e raised to 0 is equal to 1. So that I'm just writing here, so you will understand in future, 0 to infinity e raised to minus 0 t, that minus belongs to t, not 0, because 0 kept as it is, cos at minus cos of bt divided by t into dt. So when you compare with this part, you will get s equal to 0, because this part is, we can say that is this is equal to 1, and it is clearly given that is 1. So please try to understand that is s equal to 0. When we have to compare that is when the integral 0 to infinity is given. Please understand. Now one by one we have to simplify this part. So my first, we have to calculate Laplace of cos of at minus cos of bt, which is equal to, so Laplace of cos of at is very simple, that is s upon s square plus a square minus s upon s square plus b square. So that in a next step, when I have to calculate Laplace of cos of at minus cos of bt divided by t, we have to use the second rule again here, that is s to infinity f of s, means we have to calculate, or we have to put the value of what we calculated, the Laplace of cos at and minus cos bt. So I am just putting directly here, that is s upon s square plus a square into ds. I am just separating here, minus, or we can say that is, you can kept as it is. Just a second. I'm just putting directly here. So s upon s square plus a square minus s upon s square plus b square into ds. So that Laplace transform of cos at minus cos bt by t, which is equal to, again we have to use the same concept, multiply and divide by 2. So you will get s to infinity 2s upon s square plus a square minus 2s upon s square plus b square into ds. This bracket, this both are the same conceptual bracket. I just mentioned here that is a small type because of less space available. So I'm just taking 1 by 2 here. This will becomes log of s square plus a square minus, sorry, log of s square plus a square minus log of s square plus b square. Again s to infinity kept as it is. While substituting upper limit, please try to understand the part will be 0. So 1 by 2. While substituting lower limit, I'm just here applying directly instead of taking one more step. Always remember, while applying the upper limit, when the term is log, you have to put as a 0. While applying the lower limit, you have to use the minus sign, so that the negative term will be positive and the positive terms will be negative. So I am writing this part in front and this part in second with the negative sign. So log of s square plus b square minus log of s square plus a square. Now again it is clearly mentioned, that is s equal to 0. So we have to apply here again, that is s equal to 0 in this equation, so that you will understand very well. So while applying s equal to s equal to 0 with the definitions, so that Laplace of integral 0 to infinity cos of at minus cos of bt divided by t into dt, which is equal to, this will becomes 1 by 2. You will getting log of b square minus log of a square, because s equal to 0. So these two parts completely out. So remaining is log of, then hope all of you are aware about, that is log of b minus log of a, which is equal to log of b by a. So 1 by, so log of b square by a square. Now hope all of you are aware about that the term which is multiplied in front of log, we can convert this part as log of I'm just directly b by a. Hope because of this half we can shift here 1 by 2, and the term is square term, so that the 2 which is cancelled by 1 by 2. So our answer is log of b by a. Hope all of you understand clearly. Now I'm just giving one question so that you can answer directly here. Please, मुझे डायरेक्ट आंसर चाहिए इस क्वेश्चन का. मैं किसको भी पूछ सकता हूँ. प्लीज़ be active in a class. This is my request to all of you. I'm just writing here because the whole equation I'm just showing here. Okay, so the integral 0 to infinity e raised to minus 3t minus e raised to minus 60, sorry, not minus 60, I'm just taking something different one, because this will become cos of 60 minus cos of 4t upon dt. So what will be my answer? I can ask anyone, so don't say I will ask, then you can tell. So Nancy, I'm asking with you, what will be my answer? Because this is clearly a simple same format. So please justify the answer, or you can say that is what will be answer. Nancy, roll number 1, I think. Or mic is not working. Okay, yes, very good. So you have to maintain that is your mic must be working, because you must be in a class, you must be attentive in a class, because at any time I can ask a question with anyone. You can consider this is our classroom. Don't say think that is this is online, so I will just teach, because we have a lot of time here. Okay, next again I am going to ask Heth Vikam. Heth is there or not? Heth is there. 41 roll number. Heth, on your mic. Okay, I think your mic is also not working. Shivang Trivedi. Roll number 40. Trivedi Shivang. Turn off. Okay, so a lot of problems you are facing. Okay. Viraj Bhutani. Roll number 6. Don't say your mic is not working. Okay, very good. So what will be the answer?
Log of 2 by 3.
Log of
2 by 3.
3 by 2 or 2 by 3?
2 by 3.
Are you sure?
Yes, sir.
Okay, let's see. I will cross verify with someone else. So your answer is 2 by 3, right?
Yes, sir.
Okay. Suraj Chauhan,
Yes, sir.
what will be the answer?
Same log 2 by 3.
Same, 2 by 3.
Yes, log of 2 by 3.
Okay. Anyone like a different answer? You can on your mic and you can say that is a log of 2 by 3, log 2 by 3. Okay, fine. So the answer will be log b by a. So just you have to put the values, that is this is my a, this is my b. So just we have to compare with this question, so you will get b by a, so 4 by 6, so that you will get 2 by 3. Okay, so hope the question is clear and the method is clear with all of you. Now I'm moving with the next, and hope that I think this will be my last question for today's session. At last we have one more things we have to ask regarding our mini project, because this Saturday I will explain about the things which we have to do in upcoming week. So I'm taking next question here with sine function. I'm just taking, so I think it will be my third question here. Integral 0 to infinity. Maximum question will become like in this format. That's why I'm considering this format. If integral 0 to infinity is not present, you can apply directly or use first shifting theorem if exponential is given. So I'm just taking e raised to minus t sine of 2t. All of you have calci with yourself, so please carry calci with you, because this question required a calculator, so please use a calculator. Sine 3t, because I don't have a calci, into t into dt. So this is our question is given, sine 2t plus sine 3t. Now I'm not going to ask a question this time. 0 to infinity is given, so I have to compare with the definition. So by the comparison with the definition, 0 to infinity e raised to minus st into f of t into dt. Therefore this part you will getting, that is s equal to 1. Now Laplace of sine of 2t plus sine of 3t, which is equal to, now Laplace of sine 2t is 2 by s square plus 4 plus 3 upon s square plus 3 square, that is 9. Now this is division by t rule, so you have to use, that is Laplace of sine of 2t plus sine of 3t. This part is divided by t here, so when the division by t is there, you have to use s to infinity and Laplace of that numerator function. So you have to use 2 by s square plus 4 plus 3 by s square plus 9. So this will become into ds. So this will becomes what? We can integrate, or you can use the function 1 by x square plus a square into dx, 1 by a tan inverse of x by a, because here in the numerator it is a constant function, constant term. So while taking this part, this will becomes 2 as it is. Here I am taking 1 by 2 tan inverse of x by a means s by 2, because if I compare this part with the above part, that is integral 1 by a or integral 1 upon x square plus a square into dx, which is equal to 1 by a tan inverse of x by a. So my a will be 2 here, so 1 by 2 as it is tan inverse of s by 2 plus this part completed. Similarly 3 I am taking outside, this will becomes 1 by 3 tan inverse of s by 3 here. So kept as it is, so 3 3 2 2 get cancelled, and limit point kept set is as it is, s to infinity here. So while substituting the upper limit, 2 2 get cancelled, 3 3 get cancelled. While substituting upper limit, I will get tan inverse of infinity upon anything, that is equal to infinity here, plus tan inverse of infinity. So my upper limit kept as it is with lower limit minus, so tan inverse of s by 2 plus tan inverse of s by 3. So this is upper minus lower limit, so you can take that is a 2 tan inverse infinity. And what will be the value of tan inverse infinity? Anyone can on your mic and can say what is the value of tan inverse of infinity? Pi by 2? Anyone? Pi by 2, pi by 4, or what? What is the value of tan inverse of infinity? I'm audible or not? Because I'm not getting any. Pi by 2. Okay, so you are replying here. Okay. Sometimes because I'm not seeing this page, so please try to understand. I'm just open with a Microsoft whiteboard, so that's why I did not saw that is your messages. Okay, pi by 2. So pi by 2 plus pi by 2, that is equal to pi plus or minus tan inverse of s by 2 plus tan inverse of s by 3. Now there is a one formula, but you people have allowed calculator in your examination, so that's why don't use such a kind of formula, because it is a very lengthy. Again, required one more page to solve such a formula. Tan inverse of x plus tan inverse of a plus tan inverse of b in a, I think, hyperbolic functions or logarithmic you people learn, but this is not required here. We know that is by comparison with the definition we got the value of s equal to 1 at top of the function or at the top of the question. So s equal to 1, just substitute here and solve in a calculator. But while solving a mathematical equation or mathematical problems in a calculator, first you have to convert a calci in radians. Don't use a calci in that is a degree, because in degree you will get something different result, and mathematics always accept that is a result in degree radians. So please use that is a radians concept. So tan inverse of 1 by 2 plus tan inverse of 1 by 3. Please solve and just tell me what you will getting. Anyone?
So 0.785.
0.7853 in a radians or degree, because I am saying that is you have to calculate in a radians. Shift mode and just change that is a radians degree to radians, please, because I required in a radians. Answer could be similar, but we have to accept the result must be 3 pi by 4 something. ऐसा कुछ result आता है.
Yeah, so it is 45 means pi by 4, pi minus pi by 4.
Pi minus pi by 4, right? So you have to convert in radians. If you calculated in degree, you must have to convert in radians and write in form of radians instead of degree. So the answer must be 3 pi by 4. It is a very simple calculation. Just put the value of s in this equation and just you have to solve in a calculator, that is tan inverse of 1 by 2 plus tan inverse of 1 by 3. You might be getting that is pi by 4, that is 45 degree, and pi minus pi by 4 you will getting 3 pi by 4. It must be your final result. So this is the question belongs to which part, that is sine function. But again I am saying that is you have to understand what I have to show, that is यहाँ पे अगर ध्यान दोगे आप लोग तो here we calculated the Laplace of sine function directly. But in our first numericals, if I say in our first numerical the function is sine square t, but we converted that sine in terms of multiples, but that multiples was we getting in terms of cosine. So here we calculated cos. So sometimes the question arises, sir told that is the question Laplace of sine if we get, then we have to use that is the this formula only. Like this formula. No, it is not like this. Instead of understanding sine or cosine concept, you must understand this concept a upon a square plus a square or s upon a square plus a square, so that you will never forget about that is what is exactly concept. So hope this concept is very clear with all of you, so that we will sort out few more numericals in upcoming lectures, because we required more number of numericals to practice here. By Friday I will update one tutorial or one assignment sheet, so you have to just practice with yourself with that questions, because tutorial or assignment I will conduct, because already I told about we are creating a group of 5 students. Hope the 5 students groups already generated here, already you people created by yourself, because I given a freedom to all of you, that is you must create with yourself. Is Laplace transform which we learned today, or that is a division by t concept, because division by t concept and the multiplication by t concept both are the different things. In earlier method we just use that is a differentiation method, and here we applied that is a integration method. In earlier there is a t square, t cube or something, but here you will get only t, that is you will not getting that is a t square, you have to use that is a double integral or triple integral or something else, only you will getting that is a t only. There is also proof of theorem, but in an examination or in your syllabus there will be a no question will come for proofing, or you have to verify any theorems from first chapter to the last chapter or first module to the last module. Now if any students having any query regarding this concept, whatever I teach today or whatever I taught today, if anyone having any doubts regarding sir ye kaise aa gaya, or what how can we get these things, so that you have to ask clearly. Anyone, or it must be don't go, because right now there are 37 showing only. Now I'm just going to stopping the presentation, because if I will continue with the presentation I'm not going to show in attendance, so that might be questioning where I gone. So that's why I'm going to stop with the presentation. Hope all of you understand clearly with the division by t theorem. Suraj Chauhan, on your mic.
Yes, sir.
Okay, any doubt regarding this concept division by t theorem?
No, sir.
पक्का नो?
हाँ सर,
M3 क्लियर हो जाएगा?
हाँ सर हो जाएगा.
Okay, very good. So such a confidence I like during the examination, also during IIT 1, IIT 2 as well as end semester examinations. Now going to take the final attendance sheet. Attendance now again here 36 members are. I told that is I will take near about 3 to 5 times, so please don't left, because if you will left you will miss the attendance. So final attendance I am taken, that is 37 students are present in a class. Okay, anyway, if anyone having any doubts regarding the concept about any things from the first part, that is the definition of Laplace transform, first shifting theorem, second shifting theorem. Second shifting theorem you will use later on in I think inverse of Laplace transform, during the inverse of Laplace transform. Right now there is a no use in, or there is a no apply in this first part, that is Laplace transform. So now my one questions to all of you created the group with your friends, or any students left like मैंने अभी तक ग्रुप नहीं बनाया? नो, वाई नैन्सी? Why till now not created a group? Because this from by this Saturday you must create a group by yourself. If not created, I will make a group from my side from this Saturday, because Saturday when I will take the lecture, I think our first lecture, we have a first lecture with mathematics 10 to 11. That time I will ask about that is a group, and I will assign the work with the groups. Already I written that is what group have to done, or which group have to perform what during the whole semester. सो प्लीज़ मेक अ ग्रुप, बिकॉज फिर मेरे को कोई भी ग्रुप में डालूंगा, फिर बाद में आप कंप्लेन लेके आओ लाइक कि सर आई एम नॉट फाइन विद दिस ग्रुप एंड ऑल, सो दैट टाइम इट विल बी नॉट एक्सेप्टेड. मोमिन मलिहा, any doubt regarding this lecture?
No, sir.
Okay. Okay, fine. Take care. See you tomorrow. Thank you.